Robert Ladstätter. I'm a seasoned software engineer. I'm doing Java-related stuff almost 30 years now. So time flies. And in the last 10 years, I primarily worked with Scala. And I am also active in the JavaFX community. And maybe some of you know my open source application. It's called LogoRRR. It's an application to analyze unstructured log text files.
And what is very interesting from my point of view is we already had a video in this series where we saw Kotlin combined with JavaFX. And now we are looking at an application, or we'll take a look at an application which combines Scala and JavaFX. Why this combination?
Scala is a very powerful language, and it yields quite some tools for code abstractions. And I'm definitely a huge fanboy of Scala. I'm also a huge fanboy of JavaFX, and I think the combination of those two technologies yield a very good productivity. You can really focus on your problem, and there is not much syntactic clutter you have to deal with. Many of you who look at this video know how Java looked in the past, where no lambdas, for example, were part of the language specification, and you had to type quite much. This was always a criticism of Java a little bit, that it's so verbose. And here Java really went in the right direction, had many improvements, and it doesn't stop, of course. And some of those improvements, I think, were inspired by things which were initially explored in Scala.
So is the Java version, the current version of Java, catching up with Scala?
Yeah,
for the specific use cases where you preferred Scala?
Yes, Java is now very competitive, I think, in many domains, for language geeks also.
Okay, can you show us LogoRRR and how it works?
Of course. I'll just drop now a file into the application. So what do you see? You see at the left side some gray boxes, and on the right side the text. Each color here stands for a specific filter, which are listed here. So I can activate and deactivate those filters like this. Here, now I deselected everything, so you can't see any entry. But if you are interested in every log file or in every log line which contains the word severe, now you can see it like this. And the same thing with warning or info. And the typical use case is you get a file from the production system and you don't know what happened. So you search for your keywords like exception. You can just enter here exception and see, okay, did I hit exception? In this case, no, I didn't. But let's look for another word, logger, for example. And now you see in every line which is which contains the word logger is now in bright green. Mm-hmm. So and with this feature here, you can have a very quick overview what happened in the last few days or few hours when the log file was active. And like this, you can, of course, concentrate quite quickly on the interesting parts of the log file. So for example, here I see nothing special happened, but
there's definitely something going wrong there.
Here is something going wrong. Okay. And this is the main selling point of this application. It makes it easier for you to look at the log file and see where the problems happened or when the problems happened.
What I immediately notice is how fast everything reacts. So you have here over 25,000 or 25?
Well,
156,000 lines. So a big number of lines.
Yeah.
And the smoothness that you can zoom and filter and have this.
This is quite nice. It is also one, maybe we explore this also later. This is one trick I applied here to reach this performance. Because if I would have chosen to create here JavaFX nodes for each block, then this would not be as performant as it is here. Okay. So here we have a log file, 1 gigabyte, and I drop it here. So those file, this is now a 1 gigabyte file, and as like you see, you can open it quite easily. And here you have over 3 million lines of log files. And I think if your log files really get that huge, you have other problems.
Yeah, then you should have another configuration and another rotation.
Really, because there is so much redundant information then in those log files, you should really try to reduce the verbosity of your log files.
Okay, so you made me very curious what you've done in code to achieve this performance and this speed.
Like you can see, it's a Maven project. LogoRRR is a Maven project. It uses Maven to compile and build. Let's start at the beginning. Of course, every application has its main function, and the main function is somewhere here. And there, nothing special happens. I instantiate this LogoRRR app, which is a JavaFX application. So I'll dive directly to this chunk list view. This is the main class which handles this block views. And like you see, this is a list view. There are many blocks at the left side, but in reality, this is a list view. Many blocks are grouped in those chunks. And a chunk is, for example, 300 points high. And then I have to fill out those chunks with the boxes. Why is this widget so fast? And the simple truth is I just paint everything by hand. And what do you mean by it? I paint every pixel like in the old demo days with direct access to the backing array. So I write in memory in an array and paint my stuff myself. Okay, and this is the reason why this is so fast. So I on purpose didn't use the canvas approach. So this is in principle the core idea. We are using this pixel buffer class, and this pixel buffer is in principle a way to display byte arrays in JavaFX. And here we have this backing array, this int buffer, and here we write the code. And maybe here you can see this what happens. So normally in JavaFX you only use primitives like I don't know, labels or select boxes, or if you draw something, then there is a rectangle or stuff like this, or you use colors like here. But when you're using this this approach, you have to translate all those things in raw byte format. So here, for example, this color is converted from the well-known JavaFX color to ints. So here, this function here, I mean, it's not really a very complicated function, and yeah, and those will get written to this giant array. And I don't have one array, but like I mentioned before, I have many arrays stacked on top of each other, and those arrays are placed in the list view.
And you only create the pixel buffers for the data which is visible, because you have also scroll bar in there. So only the data which should be visualized is rendered, correct?
I don't know if you followed the development of Logger in this detail. I followed it, but the first version was one huge giant array, which was 4,000 pixels long, for example, or the height was 4,000 pixels. Interestingly enough, you run into problems like you can't create arrays or you can't display arrays which are bigger than a certain number, because then you get a problem with the texture mapping or something in JavaFX. So you get from every side, you run into problems if you don't use this approach like the virtual flow approach. And I initially wanted to implement the virtual flow myself until I realized I don't even need this. I just fill my content in the list view, and list view takes care of everything. I paint the arrays, but only if I have to, and I don't have to if the specific chunk is not in the viewport.
And it's, on the other hand, also a very nice example of what you can create with JavaFX and Java, Scala, whatever language which is behind it. It's just on the GVM, so that means that you have all the power of the GVM available to handle this amount of data.
I mean, I have two target audiences with Logger: the end users and the technical inclined users. So, and my goal is that it should not matter in which language a tool is implemented. It should just work good enough to be used.
Yeah, and I have to, let me share my version. I have it running here. I'm working on a few blog posts about the garbage collector. So I have some test application that I run with different versions of Azure's runtime in this case. And what I want to know is where are the garbage collector pauses, and thanks to your filters that you can add here, I can really find them back very easily. So that's really a nice thing, that you can filter them so easily and find them so easily. So yeah, I love the tool, and I definitely see a lot of use cases, and also this performance is really, really great. One thing which is sometimes hard for UI developers is testing. How do you unit test, or are you sure that the change in your UI is behaving like you expected? Do you have some kind of tests for your application?
Yes, JavaFX has a nice testing library, TestFX it's called. And one of the biggest enhancements for the last release, I think, was to create tests for JavaFX for Logo. And I want to show them how they look. So here you see that it is possible to script your UI for tests. So here, like you can see, my mouse is really moving around and is clicking every button or every link which is provided by the application, and yeah, and then it's certain metrics are tested, like was this file really opened, or is this filter really active, and things like that.
So all the tests that we just saw passing were, I think, a few hundred clicks. You didn't do anything. You just started the test, and TestFX did.
Started the test and talked about how much work it is, and it was much work. You can't believe me, but now I have how are they called? Simple search test. Okay. So how does the simple search test look like? So this is the simple search test. Okay. And I think even if you don't speak Scala, you can think what this does. And I didn't try it out. Maybe it works out of the box. Okay, so here it opens. It searches for 1, 2, 3, 4, and 5. Oh, just 4. Okay, and 0. Okay, and so if you abstract your tests in a way more or less like this, or in an equal way, you have a DSL more or less for your testers. They can formulate their tests in such a language, in a meta language, and then it's not important how if you implemented the search with a text field or in some other way, because this would then be an implementation detail of the test framework itself.
Okay, thanks for all this info. It's the TestFX is really amazing too, that you showed all these examples and how this works and how this validates the whole UI and the whole flow of data. So really great. So everyone can take a look at the source code of LogoRRR. Also the tests are open source, I guess. Okay. So people can run it locally, can check how this works and find inspiration if they want to create something similar with Scala, Kotlin, Java, whatever. But the IDs are the same for all languages. Okay, thanks a lot. Looking forward to the next 10,000 downloads. We'll keep an eye on your Twitter. Okay, thanks a lot and good luck with the application.
Okay, thank you.